Hey guys, in this session we're going to be looking at the level 1 MCAT paper from 2020. We're going to be mainly looking at day 1 of this paper. And how this video works is I actually go through each question one at a time, break it down into what you guys need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then watch the rest of the video just to see how I came about with the answer. So yeah, without further ado, let's get started. All right, guys, so let's get going with the first question here. So question one, all we have is a nice, easy question to start off with just some basic substitution. So all we're really doing in this case is we've got x equals to 2, so we need to substitute wherever x is equal to 2. And we also have y is equal to minus 3. And so we just need to substitute where that y is equal to as minus 3. So in saying that, just adjust this. What do we got? Cool. So we're going to just kind of replace all the x's and y's. So we're going to get 3 times 2 squared plus 8 plus 2 times negative 3 squared plus 2 squared minus 2. And I guess the only thing that you guys need to be careful about is this part right here, minus 3 squared, which ends up being positive 9. A lot of people make that mistake where they go minus 3 squared as negative 9, especially when they use the calculator. But in this case, we're not allowed calculators, so we can just kind of carry on with it without having to worry about it too much. So what we've got, plus 4 minus 2. So we've got to simplify this answer. We don't really need to do all the rest of the working. We can just kind of work it out straight away. So this answer is going to be 40. And of course, the grade that you're going to get for this particular question is just a straight up achieved. So if you get 40, you're going to get an achieved. But you make a mistake, there's going to be no grade for nothing in there. So this particular question, they say that you are not allowed any numerical errors. Cool. Let's go to question B. Okay, so with question B, what we have is an inequality, and we also have got a bunch of brackets there. And as I always say this, whenever you see brackets, just expand the brackets out and then rearrange it. And that's what we're going to do in this case as well. So the first thing we're going to do is we're going to expand this bracket here. So we've got 3 times 2, which is 6. And 3 times x is negative 3x. Next, we got negative 2 times 3x and negative 2 times plus 1. So we're going to get negative 2 times 3x is negative 6x. Negative 2 times positive 1 is negative 2. And this is all greater than or equal to, we got 14 times 1, which is 14, and 14 times minus x, which equals to negative 14x. All right, so now what we're going to do is we're going to simplify the left-hand side. So basically, we've got 6 and negative 2, which ends up being positive 4. And then we've got minus 3x and negative 6x, which makes it minus 9x. And all of this is greater than or equal to 14 minus 14x. Now, some of you might be wondering, it's like, do I need to worry about the greater than or equal to sign? So with inequality, just remember it is simply the same rules as when the equation equals to each other. There's only one change that you need to remember, but I'll kind of cover that towards the end of this problem as we go. All right, so in this case, we're going to rearrange everything. So I'm going to take the 14x to the left-hand side, so it becomes positive 14x because it was minus 14x on the right-hand side. I've got 14x minus 9x, and of course, I'm going to take that positive 4, which is right here. I'm going to bring it over to the right-hand side, which actually ends up being minus 4. So now simplifying this, I've got 5x is greater than or equal to 10. And then we can actually write down that x is greater than or equal to 10 divided by 2. Sorry, divided by 5. I don't know where did I get that 2 from. So in this case, we can actually say that x is equal to greater than or equal to positive 2. So the only thing you guys need to remember is this. All right, and I will kind of point this out on the side, and I do this every now and then. If you had a situation where this ended up being like this, negative 5x is greater than or equal to 10. So I'm just going to write here example, right? Because sometimes people kind of go, they might think I'm doing a completely different answer. So but anyway, so negative 5x is greater than or equal to 10. If that's the case, then you would actually go x is, this is the only time that you actually change the symbol. All right, the only time when you change the symbol is when you actually divide by a negative number. All right, so when you divide, oh, that's not a nice color to use. Let's go with this one. So when we divide by a negative number, that's the only time the sign actually changes. Cool. So this question was actually a merit question. So just to kind of give you guys inequality solved correctly, you're going to be getting a merit. So if you were getting up to here, you will end up getting a merit grade. For achieved expansion of all brackets, expansion of all brackets gets you an achieved. Doesn't even talk about simplifying, just expanding. So if it's expanding right here, you're going to be looking at an achieved. Or if you get a wrong answer somewhere, like you work through this question and you get a wrong answer, but you've done the expansion right, you could probably you'll get an achieved for that as well. Okay, so let's go to the next question. All right, so this question here, it's there's a couple of ways of doing this question, all right? I mean, like what I will try and do is when I do the day 2 version of this particular paper, I'll try and see if I can do this question another way. But and I think when you look at this particular one, cross multiplication is the easiest. But again, it's all the same kind of ideas. But I'll do cross multiplication in this one, and the next one I'll actually show you guys how to do the common factor one. But it's pretty much, I think you're still going to end up with the same kind of ideas. So when I'm talking about cross multiplication is because when I look at the denominator, I've got x plus 2 and x minus 4. And so what I mean by cross multiplication is I'm going to multiply. Let me put it like this so you can kind of see it a little bit better. So I'm going to take the 2 green parts, I'm going to multiply it. I'm going to take the 2 blue parts and I'm going to multiply it. And I'm going to multiply the pink, which is the denominator right there. So basically this is going to end up looking something like this. So we've got the 2 green parts, which is 3 times x minus 4, plus the 2 blue parts, which is 5x plus 2. And the whole thing is divided by the pink part, which is both of those two things multiplied by each other. So we got x plus 2 multiplied by x minus 4 equals to 2. So at this point, what we need to do is we need to expand the numerator. So that means I've actually got to go 3 times x and 3 times negative 4. When I do that, I'm going to get 3x minus 12. And I repeat the process for the second bracket. So I've got 5x and 5 times 2. Excuse me. You're going to get 5x plus 10. And then we've got the denominator that we've got to multiply as well. So in the denominator, we've actually got a quadratic. So we've got, what have we got? So basically just doing your FOIL or whichever method that you try and choose, doesn't really matter. I've got x squared minus 4x plus 2x minus 8. And all of this is now equal to 2. So I need to simplify the numerator. So when I simplify the numerator, I've got 3x and 5x, which is going to make 8x. Then I've got negative 12 and positive 2, which ends up being minus 2. And all of that is now divided by x squared minus 2x minus 8, and that's now equal to 2. So just a bit of a recap there, that minus 4 and plus 2x ends up with that minus 2x in the denominator. So once I have this part of the equation, now I need to cross multiply, or I could just take, the denominator to the other side, which means this is going to end up looking like this. 8x minus 2 equals 2 multiplied by x squared minus 2x minus 8. Now some of you might actually see that you can actually take the 2 to the other side and kind of simplify it further. Look, either way you do this, your answers are still going to kind of like work out real nicely. But what we'll do is we'll kind of carry on here. So what we have is on the left-hand side, we've got 8x minus 2 equals. On the right-hand side, I need to expand that bracket. So I've got all of this that I've got to kind of multiply it. So I've got 2 times x squared, which is 2x squared. 2 times negative 2x is negative 4x. And 2 times minus 8 is negative 16. At this point, I want to make the left-hand side equal to 0, or the right-hand side, it doesn't matter, but left-hand side is nicer because then you get a nice positive coefficient of x squared. So that's that 2 that I'm talking about. So what I've got is 2x squared minus 4x minus 16, and I've got minus 8x plus 2. So just remember that we are bringing the 8x minus 2 from left-hand side to right-hand side, so the symbols will change. So now what we have is 0 is equal to 2x squared minus 12x and minus 14. Now at this point you can do that, the quadratic equation where you have a value greater than 2 kind of like manipulation. But in some cases it's actually worth having a look at these numbers. Now right now I'm looking at this number 2, 12, 14. I know that 2 is a common factor, so I can actually take out 2 as a common factor. And I can write this as x squared minus 6x minus 7. Now once I do this, I can actually take 2 to the other side. So this actually becomes 0 divided by 2 equals x squared minus 6x minus 7. Now 0 divided by 2 is 0, so that's fine. And I've got a really nice, neat quadratic equation, which could be factorized as, what do we got, x minus 7 and x plus 1. And if this is the case, we've got x minus 7 is equal to 0, or x plus 1 equals to 0. So in the first answer, we've got x equals to 7. And the second answer, we've got x equal to minus 1. So grades-wise, what we're looking at for this particular question is, basically you need both of these answers to get an excellence grade. The most frustrating thing about the MCAT paper is that there's like a grading system within a grading system almost. So it's like this question, if you look at the exam schedule, they actually say that you get an award of T, and then you get 2 T's to get 2 E's, I believe. So it's like it's worth having a look at the marking schedule, which is you just have it. Yeah, for an excellence grade, you need at least 2 T's, which it's a little bit confusing, but as teachers, we're kind of used to the idea. But for a student looking at this answer schedule, it could be a little bit confusing. But just kind of know that when you get a T grade in your paper, it's just translation of E grade. But again, it differs later on. But we won't worry about that right now. What we'll worry about is just getting those right answers. All right, so what do you need to do for a merit? Now for a merit, if you use simplification of equation to a single quadratic, so you could get a merit up to here. You could also get a merit here in this area if you got consistent answers, like consistent solutions from their quadratic equation. So let's say you make a mistake at that quadratic equation, but you still can show that you've kind of solved that quadratic equation. You could potentially get a merit for this. Now for achieved, it's just does not need to be simplified. So basically we're looking at line number, this part right here is actually going to get you an achieved right there. So it's not a not a bad question in terms of like what you need to do for achieve merit and excellence. Just kind of flows nicely through. All right, so let's go to the next question. Okay, so what we have in this question is we've got 3 shapes, blah, blah, blah. All the lengths are in centimeters. Area of triangle is half times base times height. Find the value of total area given that x is 6, x, y, y. Okay, right. Fun times, isn't it? So this is one of those annoying questions. And the reason why I call this an annoying question is that, you're probably thinking, simultaneous equations because you've got an x and then you've got x, y, Suddenly you've got a Z. All right, so there's kind of like two ways you could potentially do this question. But either way you kind of do it, it's kind of odd. Like once you get the hang of it, it's actually not too bad. All right. So what I'm going to do is I'm going to calculate area. So if you look at it, the question's actually saying you get given three shapes, and they're saying find the total area for all three shapes of all three shapes. Right. So we're adding all three of these areas together. So in other words, what we have is we've got triangle plus sideways rectangle, and then we've got tall rectangle, right? So let's actually put in all our values that we know. But before we do that, we know the area of the triangle is half times base times height, plus we've got rectangle, which is also base times height, plus another rectangle, which also happens to be base multiplied by height. So the next thing what we're going to do is we're going to actually take down all of our measurements. All right, so what do I mean by that? So first up, we've got 2x here. So that's the base. So that's going to be 2x. Then we've got x that's here. That's the height. So I'm going to have x here. So hopefully you guys can see what's happening there. So the base is 2x, the height is x. Plus the second, the little sideways rectangle, we've got y as the base. And the height is going to be x. So far, so good. Plus, we've got base for this triangle, rectangle, which is x, and the height happens to be z. All right, so just to kind of give you guys a bit of a rundown, so there's my triangle there, there's my blue rectangle, and then there is my green rectangle there. So all I've done is I've just worked out my total area of all the three shapes in algebraic terms. All right. So the next thing I'm going to do is I'm looking at this thing right here. I've got half times 2, which is just 1. I've got x times x, which is x squared, plus xy, plus xz. All right, so this is the equation right now for the total area. Now, one thing that I'm always going to tell you guys is this: when you're doing the MCAT, the way the questions are written is that there's always like little tricks that's worth noting. All right, or sometimes like if you look at this particular answer, I'm looking at x squared, xy, xz. You know, the first question I got to ask myself is like, what do I notice common in this particular answer? I can see that x appears in every one of them. So what I'm going to do is I'm actually going to take x out as a common factor. All right. So if I take x out as a common factor, I'm going to get x plus y plus z. I hope that kind of made sense how all I did was just factorize it where I took x as a common factor out. Now, this is where things get a little bit interesting. You might ask why, because check this out. We've got x is equal to 6, all right? And we also what we have is we've got x plus y plus z equals to 12. So which means that entire bracket there is actually equal to 12 and x is equal to 6. So we can straight away just substitute this as 6 multiplied by 12, which gives us an answer of 72 centimeters squared. All right, so as I said to you guys, like sometimes these questions, the way they kind of the answers work out is that you just need to know when to factorize. But I always say this, if you look at an answer and you can factorize it further, just do it, and then hopefully you can kind of see the pattern there. All right, so correct solution showing algebraic procedure. So if you can get up to this part right here, you end up with a merit. As for the achieved, you can get achieved here at this line right here, or consistent factorization of total area expression. So you could get an achieved here, state y in terms of z or z in terms of y. So you can actually have y in terms of z. So it's just like rearranging. I'm talking about right here. So you know how this one was x plus y plus z equals to 12, and we actually had x equals to 6. So we got x is equal to 6 plus y plus z equals to 12. So you could write this as y is equal to 12 minus 6 minus z, and you're going to end up with y is equal to 6 minus z. So this is what they mean by y in terms of, sorry, z in terms of y in terms of z, or z in terms of y, which is the other way around. But yeah, so that's another way you could do it, which I'll actually cover in day 2 of this paper. But this is pretty much what you need to know for this particular one. Cool. Let's go to the next question there, guys. All right. Now, one thing that I would say is this type of question. All right. And I do remember kind of like going through these types of questions quite a bit in my tutorials. So if you guys haven't had a chance to kind of like check out my tutorials, check them out. There's heaps of streams up from like the last kind of few years where we end up doing a lot of these types of questions. All right, so let's actually get going with this question. So the first thing to notice is that we've got an 8, 4, and a 4. And I'll guarantee this to you guys. When they give you guys these numbers, they're going to be like nice prime numbers, easy numbers that you can rewrite them as powers of something. So what I mean by that is when you think about 4, you know that 4 is the same thing as saying 2 squared. Sorry, let's just go 2 squared is equal to 4 and 2 cubed is equal to 8. So that's pretty much what we're going to kind of like kick off with, because all we're going to do is we're going to replace the 8 with 2/3, and we're going to replace the 4 with a 2 squared. So when we do that, we're going to get 2 to the power of 3 to the power of x multiplied by 2 to the power of 2, x squared minus 6 equals 2 to the power of 2. All right, this is basically your starting point. Next thing is, remember that we have to do powers of powers. What I mean by that is this. If I have 2 to the power of a to the power of b, this is the same thing as saying 2 to the power of a times b. So that's what I'm going to do in these to remove all those brackets. And I'm going to rewrite this as 2 to the power of 3 times x multiplied by 2 to the power of 2 bracket x squared minus 6 equals 2 to the power of 2. Now the next thing is I'm going to expand the brackets and also get rid of that 3 times x and replace it with 3x multiplied by 2 to the power of 2x squared minus 12. Now if you're wondering, how did I get that 2x squared? 2 times x squared is 2x squared, and 2 times minus 6 is negative 12. And of course, all of this is equal to 2 squared. Now, remember, when we have two bases that are the same, and we are the powers actually end up getting added up if we're multiplying those variables. So in this case, we're going to get 2 to the power of 3x plus 2x squared minus 12. Now, just in case, if you forgot that, remember, 2a times 2 to the power of b equals 2 to the power of a plus b. That's all I've done in this line here. All of this is now equal to 2 squared. Now, at this point, because the bases are the same, so see how we've got 2 here and we've got 2 here, then we can pretty much say that, I want to choose a different color actually. So because the two bases are the same, then what we can say is that this power must equal to this power here. So that's all I'm going to do. I'm going to forget about the bases, and I'm going to rewrite this as 2x squared plus 3x minus 12 equals positive 2. Now make the right hand side 0. So I've got 2x squared plus 3x minus 12 minus 2, and all of that is equal to 0. Simplifying this, I'm going to get 2x squared plus 3x minus 14 is equal to 0. So at this point, remember that I need to, kind of running out of space here, but that's all right. Let's just grab all of this. Just chuck that there for now. There we go. So what we're going to do is we're going to solve this quadratic. And I think this is what we talked about before. You know, when we have, when we actually have that coefficient that's bigger than 1, we've got to do that extra bit of work Now, you might be, let me say this, you might actually know how to guess and check, that's fine. You might actually know how to use the quadratic formula and just do it in the paper, that's all good as well, because at the end of the day, all we're really looking for is the two solutions. So let's kind of do that. So we're going to go 2x squared plus 3x minus 14 is equal to 0. So I am basically looking for two numbers that multiply to minus 28 and add up to positive 3. So that's what I'm looking at. And so I'm going to go with 7 and 4. So negative 4. 7 plus negative 4 is equal to this. So in other words, all I'm going to do is I'm going to split the 3 into 7 and negative 4. So I'm going to end up with 2x squared plus 7x minus 4x minus 14 is equal to 0. Then I'm going to split them up into 2. Look at the first left-hand side of that little green line. I've got x as a common factor, which means I'm going to get 2x plus 7. And on the right-hand side, I've got, what do I got? Negative 2 as a common factor, and this is going to be x plus 7. Oh, sorry, 2x plus 7. Because remember, those brackets have to be the same. That's how you know that, okay, whether you're doing something right or wrong. So then we've got 2x plus 7 is a common factor, and we've got x minus 2 is equal to 0. So just to kind of reiterate, the x ends up being here, and the minus 2 ends up being here. And because 2x plus 7 is both a common factor, that's in the front. So what we have got is 2x plus 7 is equal to 0, or x minus 2 is equal to 0. So we rearrange this. We're going to get 2x is equal to minus 7, and then x is equal to minus 7 divided by 2. And as for the other one, we're just going to get x is equal to positive 2, because when that negative 2 goes to the other side, it ends up being positive 2. So there's our two answers, and that is what we're doing for this particular question. Now, I know this question is a long question, but most of the time they end up working really nicely. So if you, as long as you practice these types of questions, you can end up getting quite an easy kind of excellence in this, I would say, for this type of questions. So getting two solutions. So getting two solutions is getting you an excellence grade. Consistently solves, forms a quadratic equation, forms a simplified quadratic equation. So getting up to here, we're looking at a merit. And of course, if you make mistakes after this point, you can still get a merit. Achieved, there's quite a few things. At least two original numbers as correct powers of 2. So if you were to do this, you know, rewriting it with that 8 as 2 to the power of 3 and 4 as 2 to the power of 2, you can get an achieved. Yes, so there's a few more things that you can actually end up getting achieved for. If I were you, I'd actually check the answer schedule, guys, just to see what other ways you can actually get that achieved. All right, that is the end of question 1. Let's go to question 2. All right, guys, so let's get going with the second question. The second question, what we have is, again, nice question here in terms of all you have to do is just a little bit of substitution and you're good to go. So we've got a height of a person, given a formula, use the formula to find f if their height h is 160. So basically they're asking for what is the value of f when h is equal to 160. So we just write that down, 160 equals 3f plus 100. Correct solution with evidence of algebra. Jeez, that's... So in this one, you can't just... I don't know if, I think you're allowed one guess and check answer in the paper, but please don't quote me on that. But in this, the answer schedule does say correct solution with evidence of algebra. So you got to do some sort of algebra. So in this case, I'm going to take that 100 to the left-hand side, which means it's going to become minus 100. And you've got 3f is equal to that. So 160 minus 100 is 60, which equals to 3f. And then finally, get rid of that 3 to the other side, which just ends up being 60 divided by 3. So we can kind of say f is equal to 20. So grades wise, we're going to get achieved for this right here. it says that you need a correct solution for this. So anything else, you probably are not going to get that grade. So yeah, just keep that in mind. All right, cool. Let's go to the next question. All right, so the next question is what we have is we've actually got a picture is framed, 4 pieces of wood. Find the area of the picture in terms of x, given your answer, blah, 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 blah. Okay, all right. All right, so in this question, what they're asking you guys to do is find out the area of the picture, not the frame itself. All right, so if you have a look at it, first we got to work out the base of the picture, which is right here. So the way to think about it is like this. Now, if you look at the pink line, which is this rectangle here, that's 7x plus 3. And then if you look at the blue part right here, the blue part is actually equal to x. So what we can say is that the green part is the pink part minus blue part. I hope you guys can see that. All right, that's why I've actually made sure that I've highlighted in those particular colors. So we can kind of say the green part, or if you put it like this, you know, think about it, you can actually do blue, the little blue part, plus the green part is going to equal the pink part. All right, now we want to know what the green part is. So if we're going to do the green part, so we can actually say green part is the same thing as saying the pink part minus the blue part. All right, so in other words, what we have is the green part, which is the base of that picture, is going to be 7x plus 3, which is the pink part, minus x. So it's going to be 6x plus 2. All right, that's the base of the picture. So I'm just going to write maybe the picture here. There you go, 6x plus 2. Now I need to repeat that same process for the height of the picture. All right, so if I look at the height of the picture, which is that right there, what I got to do is I've got to take the yellow part, which is 5x plus 2. Do I have any more highlighters? No. Well, we just have to use a different color. Give us a second. I'm going to add another color. Yeah, it's got to go with the red there. So basically, you've got the red and orange. When you add them up, you're going to get the yellow. All right. So to figure out what the orange is, I don't even know if that's an orange color. Probably just colorblind at the moment. We can actually say yellow minus the red part there. So in other words, we're going to write this as yellow is equal to 5x plus 2 minus the red part, which happens to be this distance here, which is x. So 5x plus 2 minus x, which is going to give us 4x plus 2. So 4x plus 2, and I just realized I made a mistake here. That's fine. There should have been 3 there. So 4x plus 2 becomes the height of the photo itself, not the frame. So the picture. So now we need to find the area of this. So area is equal to 6x plus 3 multiplied by 4x plus 2. So it's just a quadratic equation, and what we're doing is just doing, whichever way that you know how to do it, that's fine. Just going to work out the quadratic equation. So we're going to get 24x squared plus 12x plus another 12x plus 6. And this is simplified to 24x squared plus 24x plus 6. All right. Now, this part is really important, and I cannot stress this enough for you guys that are sitting the MCAT for the first time. If you're ever dealing with a quadratic, all right, please do not leave your answer here. Make sure you go to here and simplify this part right there, because you do get pinned for not simplifying the expression, all right? Because particularly this question here, I mean, when I look at the answer, you're going to get a merit if you have expanding and simplifying the expression for the area of the picture, all right? So if you just leave your answer up to here, where do I say? As I said to you, if you do your answer here, you're only going to get an achieved. But if you finish the answer off, you are going to get a merit for this, all right? So please just get into the habit of simplifying that answer. Forming a correct expression for the area of the picture also gets you an achieved. So that's doing this part also gets you an achieved. All right, so let's go to the next question. So what we have in question C is we actually have a inequality. So, and looks like we've got a quadratic on both sides. So we have to actually expand this quadratic and kind of like start tinkering with it. So we're going to have 3x minus 5. I'm going to put get it out of that bracket and just kind of like expand it like this. So 3x minus 5 times 3x minus 5 is less than or equal to 3x squared plus 1. So at this point, I need to expand the brackets on the left-hand side. So once again, kind of using my FOIL or whatever method you guys want to use. Okay, it doesn't matter. There is so many ways of doing this. I'm going to end up with 9x squared minus 15x minus 15x plus 25. And that's less than or equal to 3x squared plus 1. So I've got 9x squared minus 30x plus 25. And now I'm going to start bringing all these things on the right-hand side to the left-hand side, which is minus 3x squared and negative 1. And all of this is less than or equal to 0. Simplifying this, I've got 6x squared minus 30x plus 24 is less than or equal to 0. Now 6 is a common factor, so take it out. X squared minus 5x plus 4 is less than or equal to 0. So taking the 6 to the right-hand side, it becomes 0 divided by 6, which ends up being, well, it ends up being just 0, isn't it? So what we have got here is we've got a quadratic equation, which is x squared minus 5x plus 4 is less than or equal to 0. Now, once we have this, what we need to do is we need to factorize this. So we've got, what do we got? Got 4 and negative 5. So it's just going to be x minus 4, x minus 1 is less than or equal to 0. Now, once again, I'm going to tell you guys this. If you guys have been catching up with my tutorials, you know how to solve this inequality with quadratics. You kind of need that little visual or, I always kind of say, you know, just drawing a quick little diagram will help you. So what I mean by that in this case is, remember that this right here, this is a positive quadratic, well, it's a parabola, all right? And it looks like this, and we are trying to find out what these 2 points are. Now, once again, guys, your teachers might actually show you guys a completely different way. And if it works, yeah, go for it, use it. I kind of show this way because, I don't know, it kind of helps with later on at level 2 to kind of visualize it like this. But yeah, so if you're doing this in a different way and you're happy with it, then stick with it. So how this works is basically once we factorize this, we're going to solve this. So we're going to get x minus 4 is equal to 0, or x minus 1 is equal to 0. So in other words, we've got x equals to positive 4 and x equals to positive 1. Basically, these two values that we've just solved is these 2 points right there, 1 and 4. And what we need to understand is we're looking for when is this parabola less than or equal to 0. So in other words, this line that I've just drawn here, so this is the line when y equals to 0. So if I look at less than 0, I'm looking at this particular zone here. And because those 2 points are involved, the reason they're involved is because of this symbol here where it says less than or equal to. My solution for this question is going to be 1 less than or equal to x less than or equal to 4. All right, now you don't need to draw the diagram because you can actually draw, do this question. Yeah, you can actually do this question without getting to the diagram. But anyway, this is what we're looking at. So grades-wise, correct inequality found gets you an excellence. Consistently correct solving of quadratic equations gets you a merit. Or if you get the wrong quadratic equation and you get the right answers for it, you also get a merit. Correct expansion and simplification of left-hand side. So this part here could get you an achieved, and consistent simplification to a quadratic equation. So basically, if you make a mistake after that line where you get achieved, you could still get an achieved for that as well. All right, so that is question C, and now we go to question, I think D. Yeah, let's go. These types of questions are always fun. Okie dokie. So what have we got? We've got, it seems like this question just seems to pop up all the time. You know, find the perimeter first, and let me guess, they're going to ask to find the area of the next part. Oh, it's not loading up. Maybe it'll come back. Let's see what happens. All right, so what we've got here is we've got a rectangle of paper folded along the line FH. Please move to G, blah, blah, blah. Following lengths are given. FP2, PH3, okay. Find the perimeter of the shaded region in terms of X. Oh, that's quite, oh, that's not very nice. So they want the perimeter of the shaded region. So basically what we're looking at is this line plus this line plus this part here, and this part there. So that's what they're looking for. Now, I guess the kind of thing that you kind of need to start off with is the first idea is that notice how this is 2 centimeters. So this is kind of like folded to this side here. So that's going to be 2 centimeters. The next thing is this little measurement here, which happens to be, I shouldn't have written over it. This part here happens to be 3 centimeters, which means that right there is going to be 3 centimeters. It's actually folded up. Okay, now we need to find QF. Now what I mean by QF is this right here. All right, we need to know what the length of that pink part is. So to figure out what the pink part is, if we take the yellow side, which is this here, which is X plus 3, and we subtract the 2 centimeters, which is the red, we should get the pink part. So that's what I'm going to do here. I'm going to go X plus 3 minus 2. So I'm going to end up with X plus 1. So that X plus 1 is what that pink line is. The next thing I also need to figure out is, I'm going to run out of colors here. What haven't I used? Red. No, I've used red. Pink. Little pink. Lighter. Like maybe, I don't know what you even call that color. That part right there, we are going to take, I'm just going to go back. Let's try the highlighters. So we're going to take light blue, which is going to be HS. And to figure out HS, we are going to take, need more highlighters, the red highlighted part there, which is 2x minus 5. And we're going to subtract the 3. So if you can see the 3 right here, we're going to subtract the 3 to get the blue part, which is HS. So we're going to go 2x minus 5, take away 3, which ends up being 2x minus 5. No, hang on, 2x minus 5. That's 2x minus 5, take away 3. I'm getting 2x minus 8. Cool, that all looks good. So I'm going to start adding everything up for the perimeter. So I'm going to start with, I'm going to start here and go clockwise. So then I've got 2x minus 5, which is the red part. Then the yellow part, which is x plus 3. Then the blue highlighted part, which is 2x minus 8. Plus 3, plus 2, plus the pink part, which equals to x plus 1. So just to kind of reiterate, that red right there is 2x minus 5. The yellow is x plus 3. The blue is 2x minus 8. The green part that I did here, which is going to be 3. 2 is the red line. And the pink part is x plus 1. So Combining all of this together, I've got 2x plus x, which is 3x, 5x, 6x. And then negative 5 and 3 is negative 2, negative 2, negative 8 is negative 10, negative 10 plus 3, I made a mistake. I'm going to try that again. Negative 5 and 3 is negative 2. Negative 2 and negative 8 is negative 10 plus 6. So 6x minus 4. So that's what we're looking for the perimeter. Grades wise, this ends up being a 6x minus 4 gets you a merit straight away. Establishing the expression for the perimeter gets you an achieved. So kind of getting to this part right here gets you achieved. And then if you kind of get the wrong answer, but you got that that first line correct, you can still get an achieved for that as well. All right, let's go to the second part of this question. It's always like that. Find the value of x so the area of the shaded region is 24 centimeters squared. This is a horrible question is what I'm thinking. But there's a trick way to do this, but all right. I'm just gonna copy that diagram down, guys. So just give me a second. All right, guys. So what we can do in this particular thing is we want to find, they want to find x given that the shaded area is 24. All right. What we do know is we can actually work out the area of the big rectangle, and we can subtract that little triangle and then that other triangle that's actually attached to it. All right. The reason we can do this is because if you think about it, the area of the yellow triangle here, it's the same triangle it's been folded over, which means that triangle, even though it doesn't look like it's the same, these two triangles here have the same area. Because remember, it's a piece of paper that's actually folded, right? So if we find the yellow triangle's area, which is going to be a half times base times height, we're going to get a half times 3 times 2, which ends up being 3. Now that's for the yellow part. And if it's the blue part as well, then the blue part is also going to be the same thing. It means double that, or we just add another 3. So basically we've got 6. So the blue part and the white part is equal, blue part and the yellow part of the two triangles actually add up to 6 centimeters squared. Now if we look at the big rectangle, our base is 2x minus 5 and our height is x plus 3. So working out the area for that is base times height, which is 2x minus 5 multiplied by x plus 3. And we take away the 6 centimeters squared, which is all going to give us 24 centimeters. All right. So expanding this quadratic, we're going to get 2x squared plus 6x minus 5x minus 15 equals 24. And when I move 6 to the other side, it becomes plus 6, which means it's going to end up being 30. Simplifying the left-hand side, we've got 2x squared plus x minus 15 is equal to 30. Now we've got to bring the 30 to the left-hand side to make it a nice quadratic with equal to 0. So we've got 2x squared plus x minus 15 minus 30, and that's equal to 0. So what we end up happening is we're going to end up getting 2x squared plus x minus 45 is equal to 0. Now this is the part where we got to do where, we kind of have to go 45 times 2 and split that up. So 2 times negative 45, it gives me negative 90. So I'm looking for two numbers that multiply to negative 90 and add up to positive 1, which in this case, I'm going to get 10 and negative 9, 10 and negative 9. So what I'm going to do is I'm going to rewrite this as 2x squared plus 10x minus 9x minus 45 is equal to 0. So at this part, I'm going to split them up into, do it by parts. So I've got 2 and x as a common factor. Take it out, and I'm going to get x plus 5. As for the right-hand side, I've got minus 9 as a common factor, which is going to be minus 9 times x plus 5 is equal to 0. Then I've got 2x minus 9 times x plus 5 is equal to 0. So just to kind of reiterate, if you're trying to figure out where that 2x came here, 9 ended up here, and of course because x plus 5 is a common factor, it's going to be coming out on side. It doesn't matter where you put it, as long as you have it as inside a bracket. So what we've got here is 2x minus 9 is equal to 0, or we've got x plus 5 is equal to 0. So in the first situation, we've got 2x is equal to positive 9, and then x is equal to 9 divided by 2, so x is equal to 4.5. Or in this side, we've got x equals to minus 5. Now, really important in this case, if you look at what we're trying to find in this question, is we are trying to figure out what x is. And here, what we ended up having is we've got two answers for x. One of them is negative 5, so we have to say x equals to 4.5 as x can't be negative. All right, I always say this, it's like it is just something that's good to know in terms of writing the answers out like this as well. So what we're going to do is grades wise, getting the correct positive solution gets you an excellence, sorry, not an M. Simplification of the equation to quadratic gets you a merit, so that is up to here. Consistent solving, so you make a mistake after that line, you could still end up with getting a merit. And then for achieved, forms the expression for the area. So yeah, so you're probably looking at something like this for achieved along that line. And then of course you're getting some achieved for little mixed things in there as well. Again, check the answer schedule, guys, just to see what else you can get achieved with. So that is basically it for question 2, I believe. We are going to move on to question 3 now. All right, guys, now we go to question 3 here. What we've got here is a quadrilateral, and we've got 3 angles, and they add up to 360 degrees. Lovely. So basically what we've got is we've got those 4 angles. They are actually adding up to 360. So we've got 10 times x minus 3 plus 6 times x plus 5 plus 11x plus 40 plus 9x minus 40. All of that is equal to 360 degrees. So what we need to do is we need to expand the brackets. So we've got 10x minus 30 plus 6x plus 30 plus 11x plus 40 plus 9x minus 40 equals to 360. Now the really kind of like neat thing that they've done in this is that you've got plus 40 and minus 40 which cancel out. Then you've got plus 30 and minus 30 which cancel out. So all you then have to do is just collect the x's. We got 16 plus 20, we've got 36x equals to 360, which means we can say x is equal to 360 divided by 36, which gives you 10 degrees. We can just put it as 10 actually, x equals to 10. This question here gets you an achieved, nothing less, nothing more. You need form and solve senior. Yeah, so you got to get the right answer for this to get achieved. Okay, so let's go to question B. Cool. Now this question here, and I remember, like, I think when towards the end of last year, I had a look at this question and I went, oh man, it's like, why put a parabola in there? But the truth is, whenever you get situations like this, particularly in the MCAT, right? I always say this, even if you don't kind of know like what you're doing, just substituting things and trying to kind of like try and create some sort of equation is going to actually get you a particular grade. So what do I mean by that is this. If you look at this equation here, we've got ax squared plus bx plus 2. Now, the other thing that's worth noting is we've also been given the points, because remember that we've got 4, we've got -1. All right, now these are your x values, and then you've got 18 and 13, which are your y values. Okay, so that's just something to remember. Now, if you look at the point r, and I'm just going to write these down so you can kind of get a hang of it, right? So if I take the point r is 4 and 18. So in other words, that's x and that's y. So I can write the equation now, copying from the yellow highlighted part right there. I can say that 18 is equal to a times 4 squared plus b times 4 plus 2. Because all I've done there is I've replaced x with the 4, and I've replaced y with the 18. All right, I'm literally going to repeat that same process again for q. So q is equal to -1 and 13. So I can rewrite this as 13 is equal to a -1 squared plus b times -1 plus 2. Now once again, I'm doing the same thing because look at this. -1 is the x value. So I've replaced x with -1, and the y value is positive 13. Cool. So with that in mind, what I have is I've actually got two equations. My first equation I'm going to write down here, and of course I'm going to simplify these things. So this is r right now. I've got a 4 squared is 16, so I'm going to rewrite that as 16 times a plus 4b plus 2. All right, that's one of my equations. My second equation was 13 equals -1 squared is 1, so that's just going to become a, and then b times -1 is -b plus 2. So I'm going to rearrange my equations right now. So once again, remember that this is for r and this is for q. So what I'm going to do is take that 2 to the left-hand side. It becomes 18 minus 2. And I'm going to get 18 minus 2 is 16a plus 4b. All right, simplifying this, I'm going to get 16 is equal to 16a plus 4b. And as for this q here, I've got 13, and I'm going to take away 2. That's going to give me a minus b. So a minus b equals to 11. Cool. Now at this point, what I could do is I've set up two simultaneous equations right there. All right, so you could do substitution, you could do elimination, you could do rearrange, whatever works for you. Now, normally I tend to do elimination of one of the variables, but in this particular case, you know what, let's do elimination. Let's actually get rid of the b, because I want to show you guys a couple of different variations. I'll show one variation in this paper, and then when I do day 2, I'll show you guys another variation of this kind of work. So what I'm going to do is I'm going to write my first equation down, which is 16a plus 4b is equal to 16. Now I want to get rid of the b. So what I'm going to do is I'm going to take this equation and I'm going to multiply everything inside it by 4. And you might be wondering why I'm multiplying it by 4. Because I want to get minus 4b, and then I can add the two equations. Let me show you what I mean by. So you got 11 times 4 is 44. 8 times 4 is 4a. And negative b times 4 is negative 4b. So I'm going to copy this equation into here. And I'm going to rewrite this as now as 4a minus 4b equals to 44. Now, because this is plus 4b and minus 4b, all I'm going to do is I'm literally going to add the two sides together. So I've got 16a plus 4a, which is 20a. 4b plus negative 4b becomes 0. 16 plus 44 is 60. So what I've got here is 20a is equal to 60, which means a is equal to 60 divided by 20, and I'm going to get a is equal to 3. Now once I get a is equal to 3, what I can do is I can take this equation here where it's 11 equals a minus b, and I'm going to rearrange it so that b is positive. So if I bring b to the left-hand side, it becomes positive, and a, I'm going to bring it to the right-hand side, it becomes a minus 11. Let me just write this b a little bit closer. So from here, I can see that b is equal to 3 minus 11. So b is equal to minus 8. So grades-wise, what we're looking at, getting both of these answers is going to get you an excellence. All right, correctly combining the equations in one variable gets you an merit. So getting up to here gets you a merit, and if you, let's say you make a mistake after this step, you can still get a merit. And then forming both equations, achieved. So I guess you could get an achieved here because it doesn't talk about simplifying the equations, just forming them together. Okay, so that is basically it for this question here, guys. And so let's go on to the next one. Oh, gotta love these old questions, isn't it? All right, so this question here, these age questions are always annoying, isn't it? That's all right. What we're going to do is we're going to kind of do this one way, and then the next time I do this paper, day 2, I'll try and do the other method, all right? So we're going to take Terry's age here. So we're going to put Terry's age as x, all right? Which means Mari's age is going to be x plus 4. Because whatever Terry's age is, Mari is going to be 4 years older than Terry. Now it says how many years will it take until Terry and Mari's ages in years when multiplied together makes 77. Right, so basically what we're going to do is we're going to go x and we're going to multiply it by 4, x plus 4. So because no matter what his age is, right, at some point their two ages are going to multiply to 77, and that's what we're trying to figure out, at how many years it's going to take before they get multiplied to 77. Now, if you kind of go, geez, I don't understand that, well, let's think about it like this. If Terry is 5 years old, Mari is going to be 9. All right, so when we multiply them together, we're going to get 45. Now, if you were to keep carrying on this, so you got 6 and 10, which gives 60. And if it's 7, they're going to be 11. Oh, there you go. We've already got the answer right there. All right. Now, unfortunately, we can't do this. We can't actually just do this table on this little corner and just go, in 2 years' time, in 2 years' time, their ages will multiply to 77. It doesn't work like that. You have to do it through algebra. Okay. So because we're going to do it through algebra, what we're going to do is we're just going to multiply their two ages to find out when their two ages are going to equal to 77. Or in other words, how old is Terry? So let's have a look. We're going to expand the brackets. We're going to get x squared plus 4x equals 77. Rearrange this. X squared plus 4x minus 77 equals to 0. And factorize this. So we're going to get x plus 11 and x minus 4. Sorry, minus 7, not 4. Equals to 0. So we can actually say that x is equal to minus 11 or x is equal to 7. All right. Now here's the kicker. We know that Terry is 5 years old, but the answer that we've actually got here is x equals to 7. And remember how we did this here? We knew that in 2 years' time, their ages are going to multiply to 77. So all it is that we're going to take that 7, take away Terry's age, which is 5, which equals to 2. So in other words, we're just going to say in 2 years' time. So basically, just that you can say that their ages multiply to 77. All right, so grades-wise, we have got correct positive solution found for question, units not required. So remember, we can't actually take x equals minus 11. because you can't really have negative, well, 5 minus 7 means like negative 60. It doesn't make sense. So we take that positive value. So, and making sure you take the positive value and explaining the 2 gets you a merit grade. And for achieved, forms valid equation in one variable. So there you go. That should get you an achieved, and then like if you make mistakes after that point, you can still get an achieved for it as well. Okay, so let's go to question D. All right, so question D here, guys. Anytime I see these questions, I always say factorize, factorize, factorize. All right, that's all it is. So the top line there, it's going to factorize what we've got is difference of 2 squares. So you can see that you got 4x squared and 25. Write that as 2x plus 5, 2x minus 5, and then divided by, now you got to factorize this part here, which is 2x squared minus x. Let's try that again. That's interesting. Something's up with my pen. Sorry, give me a second. Okay, so we're going to take the 2 and negative 10, multiply together to get negative 20. So basically we're looking for 2 numbers that multiply to negative 20 and add up to negative 1. So what we've got is negative 5 and positive 4, negative 5 and positive 4. So we're going to get 2x squared minus 5x plus 4x minus 10. Factorize this, so split them up. We've got x times 2x minus 5 plus 2, and we're going to do 2x minus 5 again. And we can see that this is x plus 2 multiplied by 2x minus 5. Once again, guys, if you go and check out my old tutorials, you will find lots of questions on how to do this. So you just get plenty of practice. Once you do that, we're just going to replace this with x plus 2 and 2x minus 5. And at this point, we can say those two things cancel out, and your answer is 2x plus 5 divided by x plus 2. As I said, when I tell you people this, when you see this question, you just got to remember, it's factorize the denominator, factorize the numerator, cancel the common factor, and guess what? Bang, you're going to end up with a merit for this. All right. For achieved, if you factorize either this or this, you end up with an achieved grade. All right. But as for that merit, as you can see, it's actually one of those nice kind of merit questions that pop up. All right, guys, let's go to the last question. Oof. So what we have got here is that's not a fun rearranging question, but guess what? That is an excellence rearranging question. And I reckon if you nail, or if you understand how to do this, you pretty much pretty sweet with MCAT. You'll be all right. But anyway, let's get going with this, and I'll still walk you guys through this in terms of what you need to do. So the first step that you want to really do is, the question is asking to write x, all right? X in terms of everything else. So what we're looking for, our final answer has to look something like this. X equals blah, 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 whatever. The y needs to be on the other side, the c needs to be on the other side, and the p needs to be on the other side. So we want to get rid of all of those things. So what I'm going to do is, just to start off, I'm going to start like this. X squared minus 7 over p equals y plus 3. Now you don't need to expand anything or anything like that. It's just rearranging. So the first thing I want to do is get rid of the square root button. So what I'm going to do is I'm going to square this side, which means I've also got to square the other side. When I do this, I'm going to end up with xc times x squared minus 7. And I just realized that's a p. Divided by p equals y plus 3 squared. Next, I need to cross multiply the p, so I'm taking the p across. So this is going to be c x squared minus 7 equals p multiplied by y plus 3 squared. Next, I need to get rid of the c. So the c, when it goes to the other side, it becomes divide. And again, I'm not expanding that numerator at all. I'm just leaving it as it is. Next, I need to get rid of the 7. So I've got x squared is equal to p y plus 3 squared over c minus 7. And finally, I need to get rid of the squared. So I'm going to square root the whole thing, p y plus 3 squared over c minus 7. Now, I know in the answer schedule it actually says plus or minus is not required, but whenever you take a square root of a number, it's always just good habit to put that plus or minus in the front of a square root symbol. All right. So that's basically what we needed to do in this kind of question here. It's just following it one step at a time. All right. Grades wise, correct rearrangement gets you an excellence grade. Merit, you got to do two things: consistently rearranging square root, rearranging the squared. Oh yeah, okay, fine. There's like quite a few things. So for merit, you've got to rearrange two things correctly, or at least consistently, which means you could actually make a mistake in the top line. And for achieved, it's just doing one of these things in the lines. So you could actually do rearranging the square root, rearranging the squared. No, again, it's this is just silly. So they've actually written down 4 bullet points. So if you do rearranging square root, getting rid of the squared, rearranging p and c, and then the minus 7. All right, basically, if you do one thing correctly, you get achieved, even if it's you make a mistake earlier. And if you do two things correctly, but even if you don't get to the final answer, you could still get potentially a merit. Again, if it doesn't make sense, have a look at that answer schedule and yeah, try and interpret it if you can. Otherwise, just flick me a message and I'm quite happy to kind of like go through it with you guys. Yeah, so overall, you know, it wasn't a bad paper. I mean, we had a couple of interesting questions there, but you know, I would say the achieved questions were very, very easy, and then the excellence, you know, not too bad. It's not too bad at all. Anyway, guys, look, my kind of piece of advice for you guys when you're actually attempting this paper is try and answer as many of these questions. Do not leave anything empty. Tune into my kind of like the tutorials. I'll start running sometime in July when we come back in term 3. I'll start running tutorials, so you guys can just jump in and just kind of work with me slowly as we get ready for the MCAT sometime in September. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Good revision material. And as always, thank you for watching.